Welcome back. This video is for the last learning target of the unit, which is multiplying and dividing numbers in scientific notation. Starting on page 25. Turn to page 25. Learning target, like I just said, we're going to multiply and divide numbers that are in scientific notation. So let's review really quick. Remember what scientific notation is. Remember the specialty of this first number in this first box has to be between 1 through 10. Okay? It has to be times 10, and then we have our exponent. And remember, when the exponent's positive, it's a number larger than 1. If it's a negative exponent, it's between 0 and 1. Okay? Let's start out with multiplying scientific notation. So how do you multiply numbers with in scientific notation? 4 steps. First step, we're going to use the commutative property to rearrange the numbers, and I will show you what that means here after we write these steps down. Step 2. Then what you're going to do is you're going to multiply the first set of numbers together. Step 3, you're going to add the exponents of tens. And step 4, you're going to check your notation. Okay, you're going to check to make sure that the final answer is actually correctly in scientific notation. Okay, so let's look at the first example. We're going to go through each one of these 4 steps here. First example, commutative property to arrange numbers. So we have 2 scientific notation numbers being multiplied, and we're going to use a commutative property to rearrange the numbers. Okay, so what that means is I'm going to put the like pieces together, the numbers that have no exponents. We're just going to commute them back and forth because everything's multiplication. So it doesn't matter the order that we put them in, it still represents the same thing. So I'm going to put this as 1.1 times 4.2 together. And then we're going to put our 10 to the 7th times 10 to the 2nd, 10 to the 7th times 10 to the 2nd together. So that's a commutative property. You're commuting numbers back and forth, but they all mean the same. The order doesn't matter. It all is equivalent. Second step, multiply the first set of numbers. This is where you're going to need a calculator. So let's multiply our first set. 1.1 times 4.2. So 1.1 times 4.2. 4.62. So that set right here equals 4.62 times. Third step, add the exponents of the tens. So notice we have our exponent property. Whenever we have like bases, we add the exponents. So 7 plus 2 is 9, so this is going to have to end up to be 10 to the 9th power. And last step, check your notation. Is this correct, written correctly in scientific notation? Well, is the first number between 1 through 10? Yes. And we have times 10, and it doesn't matter what the exponent is, positive or negative. Doesn't matter. That just tells us when we multiply these two numbers, it's going to be a number larger than 1. So, final answer is done. 4.62 times 10 to the 9th power. Let's give one more a try, and then you can try the third one on your own. First one, commutative property to rearrange numbers. So let's rearrange our numbers here. Put these pieces that have no exponents together. 5.1 times 4.1. And then put our exponents together. 10 squared times 10 to the 3rd power. Second step, multiply the first set of numbers here. So 5.1 times 4.1. 5.1 times 4.1. Whoops. Times 4.1. 20.91 times, and then third step, add the exponents of the 10. So 3 plus 2 is 10, so this is 10, 2 plus 3 is 5. So we're going to get 10 to the 5th power. And last step, check your notation. Now notice, our first number here is not between 1 through 10 like scientific notation is supposed to be. So we have to take what we learned yesterday, and we have to fix this issue here. We have to make it a number between 1 through 10, and then change the exponent to make up for that movement of the decimal point. So we're going to move our decimal point one place smaller, so we have 2.091. There's our number between 1 through 10. times 10. Well, if we made our decimal point one place smaller, we need to make up for that loss of place by making our exponent one place bigger. So we're going to end up with 10 to the 6th power. And our final answer, when we multiply our two scientific notation numbers, that ends up to be 2.091 times 10 to the 6th. See if you can try pausing this video and giving that third problem a try. And then check back here so you can see if you got it right or wrong. Okay, so you're checking back here. Hopefully you got to this point where you put you rearranged your numbers and you multiplied the first set, you added your exponents, and you're going to notice that it's not correctly in scientific notation. So hopefully you notice that we need to move this number, this decimal point, back 1 in order to fit the 1 through 10 rule here. So we're going to get 1.445 times 10 to the, well, because we made this decimal point one place smaller, we need to increase this exponent to be one place bigger. Final answer is 1.445 times 10 to the 9th. So that's multiplying scientific notation. So how do you do dividing scientific notation? Very, very similar, just with one difference here. So there's 3 steps in this one. Let's give you the steps first. First step, you're going to divide the first set of numbers from each other. Second step, you're going to notice it doesn't say add anymore. We're going to subtract our exponents of tens because we're talking about dividing like bases here with exponents. And then obviously the third step, you need to make sure you check your notation. Move that decimal point if you need to. So let's give this a try. First step, divide the first set of numbers. So we have 2.5 times 10 to the 7th divided by 1.8 times 10 to the 2nd. Two numbers in scientific notation that we're dividing. First step, let's divide our first set of numbers, which is nice because it's already lined up for us, so there's no need to rearrange numbers like we did in the first one. So 2.5 divided by 1.8. Let's look. 2.5 divided by 1.8. 1.38 repeating. Well, let's just write 1.39 to round it. Okay? Times, step 2, subtract the exponents of 10. So we have like bases, so we're going to subtract. Remember our exponent rules. 7 minus 2 is 5, so we're going to get 10 to the 5th power. Third step, check notation. Looks like our first number is between 1 through 10, so we're good. And it's times 10, so there's our final answer. Let's take a look at a second example. Divide the first set of numbers here in our scientific notation. We have scientific notation divided by scientific notation. 4.1 divided by 8.2. 4.1 divided by 8.2. 0.5 times 10, because our bases are 10, and we're going to subtract our exponents of 10, so 4 minus 8. 4 minus 8 is -4, not 4 because it's always top minus the bottom. Let's check our notation. It looks like this number is not between 1 through 10, so we have to make it a number between 1 through 10. So let's move our decimal point place one place bigger so we get a 5, which means if we moved our decimal point one place bigger, we have to make up for that gain by losing an exponent place. So we have to make our exponent one place smaller. Well, one number that's smaller than -4, think of on a number line, we're going to move it to the left, is going to be -5. Okay, so final answer, 4.1 times 10 to the 4th divided by 8.2 times 10 to the 8th is 5 times 10 to the -5th. Okay, go ahead and pause, give the third one a try, and check back here for your answer. Okay, hopefully you got this far. You got 1.1 divided by 5.2. I just rounded to 0.21, and then times 10 to the 3rd power, because 5 minus 2 is 3. Check notation. It's not a number between 1 through 10 to correctly say it's in scientific notation, so we're going to move our decimal point one place bigger to get 2.1, which is between 1 through 10, which means if I made this bigger, I have to make this one place smaller. One number smaller than 3 is a 2. Final answer, 2.1 times 10 to the 2nd power. Okay, so if you're at all confused between multiplying or dividing scientific notation, please pause and make sure you're asking. Last two problems. let's take a look at how to use scientific notation to problem solve some word problems here. First one says, the speed of light is about 1.86 times 10 to the 5th miles per second. So it's a large number, which is why it's written in scientific notation. About how far does the light travel in 68 seconds? Well, I know then if this is the speed per second, and I want to know how many or how far it goes in 68 seconds, I want this number 68 times. So I'm going to have 1.86 times 10 to the 5th power, and I want it 68 times. Okay, so this is multiplying scientific notation. So what I'm going to do, same thing, I'm going to arrange the numbers together, commutative property. So I have like numbers together, so there's 1.86 times 68, and then we'll keep the times 10 to the 5th out here. So just a rearrangement of numbers here. Calculator, let's do 1.86 times 68. 1.86 times 68. 126.48. 126.48. And then we're going to keep the times 10 to the 5th. Okay? And the last part, is our notation correct? Well, we have a number that's way bigger than 10, and it's not between 1 through 10. So it looks like I'm going to place my decimal point right here. So I'm going to end up with 1.2648. Okay? It looks like I moved our decimal place 2 places backwards to make our numbers smaller, to fit the scientific notation rules. Which means if I made this 2 places smaller, I have to make this exponent 2 places bigger to make up for this loss here. So this is going to have to be 5 to the 7th power. That means in 68 seconds, light is going to travel 1.2648 times 10 to the 7th miles. So it's a fairly large number here. It should be larger than this number, obviously, because this is miles per second. This is how many miles in 68 seconds. Okay, last one. It says the average flow rate of the Amazon River is about 7.6 times 10 to the 6 cubic feet per second. That means the Amazon River is flowing very, very, very quickly. Okay? The average flow rate of the Mississippi River is 5.53 times 10 to the 5th cubic feet per second. So it's not flowing as fast. Find the ratio. Ratio is your clue, your keyword here. Find the ratio of the flow rate of the Amazon to the flow rate of the Mississippi. Well, ratio here means I know I'm going to compare one to the other, and we're going to use division. Okay, it specifically says find the ratio flow rate of the Amazon, so we want Amazon compared to the flow rate of the Mississippi. So Amazon to Mississippi, the order here matters here. It doesn't say Mississippi to Amazon. So what I'm going to do here is, let's write out this problem. I know that the flow rate of the Amazon says Amazon is 7.6. So 7.6 times 10 to the 6th. And then our Mississippi here, Mississippi River is this number, divided by 5.53 times 10 to the 5th. So we're going to find the ratio, the difference between the two. So let's go and follow our rules here. Let's divide our first set of numbers. 7.6 divided by 5.53, about 1.37, let's write. Let's just round it 1.37 times, and then we know that like bases, when we divide, we're going to subtract. So 6 minus 5 is 1, so we're going to get 10 to the 1st power. And it looks like it's already in scientific notation because our first number is between 1 through 10. So this means that the Amazon is 1.37 times 10 to the 1st power, which means it's 13.7. It's about 13.7 times quicker than the Mississippi. Okay, that's the ratio. Okay, let's go ahead and close with a summary here. First summary piece. When you multiply and divide scientific notation today, I want you to be very careful. Don't just stop after you multiply and divide. Be sure to check your notation. Just make sure it's in scientific notation in your final answer. Okay, if it's not, and that means that first number has to be between 1 through 10, that's the main thing you have to check. You're going to have to be moving some decimals and changing some exponents. So a good reminder here is if you move your decimal one place bigger, then your exponent has to become one place smaller. It's always the opposite. It's not the same change. Okay? And likewise, if you make your decimal point smaller, then you have to make your exponent bigger. So it's always the opposite direction change. Okay? All right. Go ahead and give your classwork a try here. Log in and check your answers. Ask any questions. Good luck.